Welcome to Train Signal. In this video, we're going to learn what TCP/IP is. We'll take a look at the TCP/IP architecture, then we're going to take a look at all the little protocols that work together to make up the TCP/IP protocol suite, and then we'll look at the different types of communication that are used by TCP/IP. So, what is TCP/IP? Well, technically, TCP/IP stands for the Transmission Control Protocol Internet Protocol. But simply put, TCP/IP is the basic communication protocol of the Internet. Now, even though TCP/IP was designed to be an Internet protocol, it can also be used as a communication protocol within private networks as well. As a matter of fact, it's probably more widely used than any other communication protocol in today's corporate networks. Now let's talk a little bit about the architecture of the TCP/IP protocol. TCP/IP is based off something called the DARPA model. This is a 4-layer communications model in which each layer corresponds to one or more layers of the 7-layer OSI model. And we talked all about the OSI model in the last video. Each of the 4 layers of the DARPA model have individual protocols which all work together to form a protocol stack. Now this is more commonly known as the TCP/IP protocol suite, but we'll come back to that in just a few minutes. First, let's look at the DARPA model. Now as I mentioned a moment ago, the DARPA model is a 4-layer model, and the names of those layers are the application layer, the transport layer, the internet layer, and the network access layer. Now each of these layers corresponds with one or more layers of the OSI model. So let's look at these side by side. Here we have the DARPA model on the right and the OSI model on the left. You'll notice that the application layer of the DARPA model aligns pretty much with the top 3 layers of the OSI model. The transport layer, this is an easy one, it aligns itself with the transport layer. The internet layer aligns itself with the network layer. And then finally we have the network access layer, which aligns itself with the bottom 2 layers of the OSI model. Now, there's not necessarily this perfect one-to-one correlation between the 2 models, but it's pretty close. And if you watched my last video where we went through and talked about what the functionality of each of the layers of the OSI model are, you should have a pretty good understanding then of what takes place at the different layers of the DARPA model. The other thing that you should know about the DARPA model is that communication works the same way as the OSI model, in the sense that the sending computer will start out with some raw data. That data will be passed down through the DARPA model, with each layer adding its piece of information to the data so that it can then be transmitted across the network. And when it gets to the receiving computer, it then has to go up through the DARPA model until you end up with raw data for the receiving computer. This is exactly the same way that communication takes place through the OSI model. Now let's take a look at the TCP/IP protocol suite. As you can see here, at each of the 4 layers of the TCP/IP or DARPA model, we have individual protocols that all work together to make up this protocol suite. So if we start up here at the application layer, you'll see here that I've listed some of the more common or more popular or more well-known application layer protocols. There are many more than this, but I just wanted to put some out there that you might already have some familiarity with. For instance, just right off the top here, we have HTTP, which is used for internet browsing, or FTP, the file transfer protocol, for transferring files, SMTP for mail transfer, etc., etc., etc. We're not going to go into any real detail on these application layer protocols because, quite frankly, there are just way too many to talk about. Now, likewise, I'm going to jump down to the bottom, in which I have listed Ethernet and Token Ring. These are considered to be low-level protocols. And it kind of makes sense low-level because they're down in a low layer of the protocol suite. But these low-level protocols really have to do with more of the physical makeup of the network itself. But what I want to focus on are these middle layer protocols, and there's 6 of them here that you should be familiar with. So let's take a look at each one of those individually. Here we have our transport layer protocols. There are 2 of them, and they are TCP and UDP. First, let's talk about TCP. TCP stands for the Transmission Control Protocol. Seems like I've heard that somewhere before. Oh, that's right. It's part of the name TCP/IP. Well, anyway, the TCP Transport Layer Protocol is used with one-to-one communication between two computers. It provides for connection-oriented communication. Now, let's stop there for a moment. What does it mean, connection-oriented? Well, connection-oriented communication means that a connection must be established first before data can be exchanged. TCP uses something called the three-way handshake to establish this connection. Let's take a look at how the three-way handshake works. The first leg of this three-way handshake starts off by some computer wanting to initiate communication by saying, "Hi, I would like to talk. Here's information that you will need to communicate with me." The second leg of the three-way handshake is then with the other computer receiving that information and saying, "Thanks, I got it. And here's the information you will need to communicate with me." And then the third and final leg of this three-way handshake is the original computer saying, "Okay, I got your information. Now, let's begin talking." And that is how we establish a connection-oriented communication with the TCP Transport Layer Protocol. We know that we use TCP with one-to-one communication. We know now that it's connection-oriented, but we also have something called reliable communication. What we mean by reliable communication is with all TCP communications, there's an acknowledgement of receipt. So I send you something and then you say got it. I send something to you, you say I got it. That's how the TCP Transport Layer Protocol works. Now let's talk about UDP, the User Datagram Protocol. Unlike TCP, UDP is connectionless. Okay, so there is no three-way handshake. We just start talking. It also provides for unreliable communications in the sense that there's no acknowledgement. We just send it out there and hope you get it. I kind of compare this to sending a letter through the mail or sending that letter via certified mail. Sending it through the mail would be like UDP, where it's unreliable. You just send it and hope that somebody got it. Whereas with certified mail, you put it in the mail and then there's an acknowledgement that it's been received. That would be like the reliable communications of TCP. Now you might be thinking to yourself, well, why the heck would we ever use UDP? I mean, TCP sure seems to be like a good, reliable transport layer protocol. What would be the purpose of UDP? Well, you'll notice under UDP I did not write one-to-one communication, and that's because UDP, although it can be used in one-to-one communication, is typically used when one is trying to communicate with many. And we'll talk about some of the different options where this might be available, but let me give you more of a real-world example. Let's say you like to listen to your favorite radio station on the internet, right? We hear that advertised all the time, streaming worldwide. Well, that streaming audio, where the radio station's website is just putting that audio out there on the internet for it to be heard, is done so without any acknowledgement from its recipients. When you listen to that music, or maybe it's talk radio, on the internet, it's sent out there and hopefully you get it. And if you don't, if maybe you miss a couple of frames, maybe there's a little hiccup in the song that you were listening to, there's no acknowledgement of that. The radio station doesn't stop and rebroadcast that. They just keep going. And that's how UDP works. Now let's take a look at the Internet Layer protocols. First one I have listed here is IP, the Internet Protocol. Now, besides the fact that we see that name because it's part of TCP IP, the other place where we see IP typically is where? With an IP address. And that is what IP's purpose in life is. It's for addressing, the addressing of the information, giving an IP address. And along with that comes routing as well. Now another protocol that we have here is ARP, the Address Resolution Protocol. This resolves an IP address to a physical hardware address. Now we'll learn about this a little bit later, but computers do not actually communicate using an IP address. They use the IP address for routing and for identifying themselves, but computers actually use the physical hardware address to directly communicate with one another And ARP is what is used to resolve the IP address of a computer down to that physical hardware address. Now, another internet layer protocol we have here is ICMP, the Internet Control Message Protocol. It's used for diagnostic and error reporting, most typically when a piece of information doesn't end up getting to its intended destination. Very often, ICMP will be used to try to send an error message back to the sender, letting them know that their information didn't get where it was supposed to go. What I like to think of it as is it's kind of like when you send a letter through the mail, and instead of getting to your friend, let's say, it comes back to you stamped return to sender. Something happened in that transmission process and it failed, and so the post office tries to help you out by sending it back to you saying, hey, it can't, stamped return to sender, can't get to where it's going. Now, ICMP does not make TCP/IP a reliable or a more reliable protocol. It just tries to by using these error messages. And the last one we have here is IGMP, which I will caution you right out the gates, don't confuse IGMP with ICMP. You'll notice they look very, very similar. The I, the M, and the P are the same. And then all that's different is the C and the G, which physically almost look like each other when they're written. So IGMP stands for the Internet Group Management Protocol, and it manages IP multicast group membership. Now, you don't know what a multicast is, and we're going to actually talk about that next. But when we have multicast communication, you'll see that there is a membership to a multicast group, and IGMP is what manages this membership. And those are the internet layer protocols. So let's go ahead and talk about the different types of TCP/IP communication. We have 4 of them here. We have unicast, which is where we have one-to-one communication. Multicast, just talked about that a moment ago, where we have one-to-many, or a broadcast, where it's one-to-all or one-to-everybody. And then something that's brand new to TCP/IP version 6 is this anycast, which is where we have one-to-one of many. Let's look at each one of these individually. First, we have unicast, which is one-to-one communication, and it's just what it sounds like, one-to-one. You have one sender and one recipient, and these two computers are talking directly to one another, and all the rest of the computers on the network aren't paying any attention at all. Just these two computers are communicating back and forth. That is a unicast. Now, the next type of communication we have is something called a multicast, which is one-to-many. When you see that illustrated here, we have one sender, and we have 1, 2, 3 different recipients listening. And the way that you send from the one to many, but not everybody, because you'll notice here that there are the 3 computers in yellow, which are not even paying attention to this communication. They're not involved with it. The way we accomplish that is by creating what's called a multicast group. We'll have a special multicast address that we transmit on, and anybody who subscribes to that address will then receive the communication. This is very often how that streaming audio that I spoke about a few minutes ago, that's how that streaming audio works. Very often it's being put out there, and it's not being sent to everybody. It's being sent to everybody who is subscribing, who wants to listen to that information. Next, we have the broadcast. Now, broadcast is one to all or one to everybody. And what that means is this computer will send out information on a special IP address that says, hey, everybody, you all must listen to me. Every one of you must go ahead and receive this information. That is what a broadcast is, just what it sounds like. You're just yelling out to everybody. And then finally, we have the new type of communication only available with IP version 6 called the anycast. And this is one-to-one of many. Now, that might sound confusing right there. I know it was to me when I first saw it. Basically, here's how it works. Similar to a multicast communication, we have a number of different computers who will all subscribe to a special anycast address. But what happens is when the sender sends something out on this special address, it will be delivered to the one computer that is closest or most easily accessible on the routing table from the original sender. So the sender sends out, and it goes out, it takes a look and says, okay, this one computer over here is the closest who subscribes to that special address, so I will send to that computer. And then we actually have one-to-one communication going on between those two computers. So Anycast is kind of like taking unicast and multicast and putting them together to create a new form of communication. So those are the different types of communication we have available with TCP/IP. Well, that wraps up this video, and after watching, you should now understand the TCP/IP protocol architecture, and you should understand that it is based off of the 4-layer DARPA model. And in each one of those layers, there are individual protocols that collectively make up the TCP/IP protocol suite. And you should also now have a pretty good understanding of the 4 different types of TCP/IP communication: unicast, multicast, broadcast, and the new Anycast.